Hello world, this is CS50 Explained, week 1 continued. We're here with CS50's own Dan Armendariz.
Hey everyone.
Let's take a look.
Alright, this is CS50 and this is the end of...
I didn't notice before that someone was passing a laptop around in the back. Did you see that?
Oh really? I missed that.
It's sort of like the CS50 equivalent of a beach ball at graduation.
That does tend to happen. People start passing laptops around in the orchestra.
Have many people started tossing beach balls around?
No, that's never actually happened, but thank you for making the suggestion on the internet. I'm
That
sure
would be more
this will happen.
interesting.
So this is CS50's own Ansel Dolph, a former advisee of mine and an engineering sciences concentrator, which means he is an engineer, and he actually spent this past summer with us, as you may recall.
So I noticed that you don't actually allow many student groups to actually have, as you would say, advertisements at the beginning of lectures. So why allow it in this particular case?
So that is true. We tend to get asked most every week if we can publicize something in class because we have such a large audience of students who are captive at the beginning of class, and we almost always say no unless there's some connection to the class or to computer science specifically. So in this case, Ansel spent 3 months with us and really opened my eyes, honestly, to what can actually be built fairly readily using a combination of software and then of course hardware. He, for instance, made our CS50 doorknob on the office door, which is actually fabricated out of thick aluminum. He made a series of CS50 letters out of steel that he laser water jetted, which was pretty cool to get exposed to as well. So he was really this interesting intersection of hardware and software this past summer, and so he's involved at MIT with a student group that actually builds cars, builds racing cars of their own, and handles all of the engineering behind that. So it felt only fair to give him an opportunity to help find his successors for that program as he's graduating this spring.
I think in general, even though CS50 doesn't do it necessarily for a class that's using the CS50 curriculum, it can be kind of a powerful thing for them to bring in student groups of diverse interests, but you're even somewhat related to computer science, and have them do little advertisements at the beginning of class and get more people interested in that. But
more than just advertisements. Like one of the goals was for Ansel to actually bring in these visuals, paint a picture of what you can actually do.
But I think the bigger point is that, the point that I was trying to make before is that it's useful, I think, for students to see that computer science is not just about the stereotype for programming in a basement, and there's the opportunity to program in a car, or program a car in this case.
In a box with a fox.
Maybe you could actually do it in a basement as well.
Yeah. Well, he introduced me at least to CAD, whereby he actually used 3D modeling software to create things, even some funny things like little 3D elephants, which we started giving away, and little iPhone stands.
Did you program the elephants?
Well, he downloaded the image file, or at least one of our other teaching staff did, and then printed them on our 3D printer.
Right. No, but he was actually, he gave a little tutorial in the office, I remember, about how to use CAD, and that was actually really useful, I think, for all of us to see. And his skills were impressive in just modeling things. I remember many of us were impressed. He was able to just model things out of thin air, essentially.
And in fact, the lectern, which is not currently visible but is holding those laptops, he fabricated that as well, and actually CAD'd it up, and then we outsourced it to someone who could actually cut the metal and solder everything together for us. And if I can make one advertisement of my own, I actually genuinely think that a mistake I made in college was not taking an engineering class. I mean, as I say in CS50 usually, discovered computer science somewhat late. Didn't dabble in it in high school, and didn't take CS50 myself here at Harvard until sophomore year, so a good year into my 2 years into my 4 years of college. And I regret, honestly, not having made time for something more hands-on as like an engineering class. It took me till just this past summer to really appreciate what you can do.
But do you mean like a mechanical engineering class? What sort of because there's also like computer engineering, which is not necessarily...
Correct, mechanical engineering, and actually building things. It's actually a lot easier and a lot more accessible than I actually thought it was. I sort of never thought of myself as a hardware person, and I surely couldn't do what Ansel does, but now I understand what tools you can use and how you would go about doing it, even if my lectern might not be structurally sound. So this is, speaking again of advertisements, this was actually just a video that IKEA put out. Actually, I think it is a legitimate IKEA commercial they put out this past year, sort of spoofing all of the technology commercials, especially Apple-like commercials.
Very iPad.
Poking fun of, how their printed catalog for all these years is effectively equivalent, if not superior in some ways, to an electronic device.
Right.
if you want to get a quick overview.
So why show this in CS50, you ask? Well, so I actually do try for as many lectures as I can to find some silly element that's somehow ideally tangentially related to the class so that we can sort of justify it. But it's really meant to be, when we hit play at the start of a class, to just draw people in and get them sort of warmed up and excited about what's to come, even if the connection to class is a little bit of a stretch.
Yeah, that was questionable.
But it's fun. But we wouldn't use it again because next year it'll be passé. But it was actually well timed, its release. And so I actually, for class, keep an eye on like popular tech news and blogs and whatnot. And generally, it's just this infinite stream of potentially interesting material for class.
What are some of the ones that you pay attention to?
I mean, definitely secure. Oh, in terms of sites.
Yeah,
I was TechCrunch.com is a good one. For a while, I was looking at Engadget, which focuses on hardware gadgets, but less so these days. Slashdot.org, which is a popular one as well. Mashable tends to have some interesting things. But to be honest, I'll admit I tend to just keep tabs on certain techie friends on Facebook and the like, who tend to draw my attention to things they have read. I don't spend a huge amount of time trolling myself through all of those sites. So super sections is something we might make mention of, since CS50, of course, is the tradition of sections, which are small-scale classes led by the teaching fellows with just 12 or 15 or 20 students in the class to make a large class feel smaller. They generally review material in those classes, go into more depth, or do practice problems with students. Super sections is really just a one-time thing that we do at the start of the semester when we haven't yet had enough time to figure out the staff's availability, the students, their class schedules, and so we can't section students, so to speak, and put them into days and times. So super sections, we hold 2 or 3 or 4 of these each fall in the very first week or so that are open to all students, just to make sure that we have the support structure from the get-go.
So what are the difference between sections and office hours?
So where sections are these 15 or so person classes with a formal structure, office hours are really just an opportunity for one-on-one help, where students go to space on campus, where we generally have, in our case, 20 to 30 teaching staff on duty, but we can surely do the same idea with just 1 or 2 people there. And it's an opportunity for students to call a staff member over if he or she is struggling with some bug. And really the goal of office hours is just to provide one-on-one support, and generally to help unblock students, to get them past some hurdles so that they can dive in and start focusing again independently on the week's piece.
So the slide that just came up before was the course's discussion board, CS50 Discuss. So there's a lot of different ways for students to get help in sections and office hours and discuss. Which are the ones that get the most traffic, the most questions?
Oh, it's a good question. Within the CS50 semester on campus, CS50 Discuss tends to get quite a few. And CS50 Discuss is our own discussion software that we happen to use internally each semester. And there's many hundreds of questions and answers that are posted there, but we also have attendance at office hours these days of 50 students on the quietest days and 300 plus students on the busiest of days.
Out of how many?
Out of 800 students in the class. And so this has actually been a trend in recent years where more and more students are attending office hours, not so much because they're struggling any more than they historically were, but because it's kind of become the thing to do at night. Even if you don't necessarily have any questions a priori before getting to office hours, people have started to hang out there. And I would attribute this, I think, to the cultural change we made just a few years ago. We used to meet for office hours in the basement of Harvard Science Center, which is this wonderfully awful place to spend an evening because it has fluorescent lights. We were literally in the basement computer lab with cubicles and workstations, and it was just not a fun place to spend an evening. And we realized just a few years ago that almost every student upon arrival at office hours was pushing the workstation's keyboard out of the way and putting down their own laptop. And so that made us realize we can untether ourselves, and so we actually moved to the undergraduate dining halls or cafeterias, so that there's some free food late at night, drinks and snacks and so forth. And also it's a place that's open to all students in and out of CS50. And the hope was that if I'm in CS50 and you're not in CS50 but working on a humanities problem set or STEM piece set or really any other homework assignment, that I might look over your shoulder, you might look over mine, and take a genuine interest in the kinds of cross-field work that we're doing.
Have you noticed any sort of intersection in the students that take advantage of these various resources? So in other words, do you notice that it's the same students taking advantage of both Discuss and office hours and sections, or is it different groups of students that might learn in different ways?
More so the latter. It tends to be self-selecting. In fact, many students never even post on Discuss, which is fine so long as they're looking for answers, but I would say a worrisome number of students don't even look at Discuss for answers, and so I
Or
think
even know that it exists.
or know that it exists in some cases, and this is a communication failure on our part, or a failure to connect with the student and make clear to them the resources that exist. And because for us, that's an expense in terms of time, because if they're not taking advantage of some very searchable resources online and instead coming in person, it's fine if they want that human-to-human support, but if really they're just asking a question that could be frequently asked online and answered canonically, that I think is a failure. And so we've actually been trying to get better at that. But just a couple years ago, we tried to, I think we overcorrected, and in fact, for office hours, rather than have students like write their name on a sheet of paper, as we did in the years past, or on like a whiteboard to say, I need help, or rather than just have them raise their hands physically, we added a virtual hand raise capability to CS50 Discuss, so that students could click a button on the website, then the teaching staff would essentially get a notification that someone is in need of help, and they could then go over to them or vice versa. But we therefore channeled students ideally through the electronic forums first, and only when a human staff member decided this question is best answered by a human in person and not by typing a reply, would we actually dispatch a staff member to help the student. And this actually wasn't well received, because it felt like a mechanization of the course, that we were suddenly becoming colder towards students and sort of forcing students to go through the discussion software before we would even see them. And this wasn't the intent to distance ourselves. It was really meant to give them faster answers because of the canonical answers online already. But there was a perception challenge, and so we actually moved away from that for that and for other reasons. But that was an unexpected outcome.
So what did you go back to? What do they do now?
So we've gone to something more organic, to be honest. The digitization of office hours, the virtualization of hand raising, so that we could actually measure how many students had questions, what the wait time was actually creating these significant bottlenecks, since we only have, quote unquote, 20 to 30 staff members on duty, but we had as many as 200, 300 students there. And the reality was, students realized quickly that there's enough people there with questions, such that even if you don't have a question yet, you should probably just raise your hand virtually now, so that when you do have a question in 20 minutes or in an hour, you're already going to be in the queue. And this was not good, because it effectively meant that the moment office hours started, 200 people were in the queue, because they knew that demand was going to be high ultimately. So it devolved, I think, in just a horrific wait times. And so we moved to something more organic, where now we have staff just mingling around in the cafeteria, looking for students who might summon them over casually or raising their hands. And it's not perfect by any means, and we lose access to all of the data and what questions students are asking and what our response times are in terms of collecting that. But we have enough data from the past years to kind of estimate how things are going to go, and it's been better overall to sort of put technology aside and just try to approximate smaller scale office hours.
It does seem like it might need, excuse me, a further revision, because when I participated in office hours last year, there was the same issue with the queue, but now with hands. So what would happen is that most students would end up having their hands raised for a significant portion of the time and having to type with one hand at the same time. So there's a downside to that way as well.
No, I know, and I agree. In fact, I think it's a ratio issue in particular, because the students who are coming to office hours should feel comfortable and inclined to ask questions. But if our response times are too low, or if it does devolve into a situation where you're trying to program while raising your hand, this certainly benefits no one. So it occurs to me that there's week one continued on the screen here. And we're swooping in here at a point where we had a couple of student volunteers, essentially being the human incarnation of two functions, getString and PrintF. In this case, the student who's up at the board there is representing the function PrintF, so she is herself PrintF and printing by drawing on the screen. And the other fellow who was pictured a moment ago was representing getString, and was the physical incarnation of something that could go physically get a string from someone in the audience in our case. So I didn't like how this demonstration went in the end. This was the very first time we tried this. My goal was to paint a more visual picture of what functions are. And I liked the idea, but I think it dragged on a little long.
And Javier was down here
There we
for
go.
joining us up here.
So I think there's still some potential in this idea of having one student
So now
print
let's take for
something
granted
as
just
per
how
the sample code
straightforward
we
all
had
of
for
that
Hello World
might
program,
be.
and another
But let's
student go
proceed to
physically get a
actually
string
do
from another
something in
user.
actual
But I think we
code.
need it
So
to
up
be a
on the
little more
screen here is
immediate,
a
because it's a
screenshot
3-line
of that
program that
so-called
we
CS50
spent and
Explained.
talked
And if
over
you
multiple
had
minutes
to,
of.
as of 2 p.m.
But at
on
the same
Wednesday
time, it
afternoon,
seems like
explain
it's
to some friend
pretty easy
what the CS50
conversion.
Explained is, how
It's
would
not
you
that
define
much of
it
a
in
stretch, I think, for students to, having just been exposed to Scratch and presumably have started
Anyone
working on
said
their
this?
Scratch
Yeah.
bomb sets, to look at that relatively simple C program and know a little bit of what's going on.
It's a
Perhaps a
program that
short
enables
explanation is
everyone's
in order
computer to run on the
to
same system.
get
It's
them
sort
over
of
the
your own
hurdle
copy
of
an
trying
operating
to
system that
understand
happens to
the
be called
syntax and
Ubuntu
it has any
Linux.
sort of
And it
semantic
runs
meaning.
effectively inside of Windows
But
on
beyond
your
that,
own Mac or PC,
is
so that this way,
a demonstration
right out
like
of the
this
gate in
even
week one,
necessary for
everyone
something
here in
like
the
that?
class
Is it
has access to
instead
the
better
same tools, the
to
same configuration. There's no
decouple,
learning curve
is it
specific to
instead
the
better
Mac
to
or
focus on
PC in
decoupling the
particular.
syntax
Now, we opened
and
up inside of the CS50
the
appliance
aspects
on
that actually
Monday. This
provide
program here
meaning,
happens
or
to be called
at least
gedit,
pointing out
but
what
that's
aspects
really
of the
just a
syntax
graphical
provide
editor,
meaning?
something like
It's a good
Notepad or
question. I
TextEdit
definitely
on
agree
Windows or
that
Mac OS
for
respectively.
many
And I
students, the
proposed
leap
that
from
there were
scratch to
really
C
three important parts to
shouldn't
this
be
tree.
so wide
The
as
top
to
side
make
is where you would
the
write your
existence
code,
of
and that's
PrintF
where
and
we spent
getString
much of our
much of a
free
mental leap.
examples in,
But I would
in
actually,
Monday's lecture. The bottom we called what?
in which case, this example could even go earlier in the semester, just 1 week prior, when we're first talking about statements in Scratch and what it means to be a puzzle piece that represents a statement, like say, or the like. Say, fortunately, is very straightforward. But I would expect, don't know, can't back this claim with data, this is more intuition, but I would expect, based on Q&A we've had with students, that as soon as we go down to this lower level, this textual level, things do become a little more abstract. And if you weren't completely comfortable in the world of Scratch, it might very well be the case that having this physical bridge, where getString is just this little black box, or in this case some human who knows how to do something well, and he or she goes and does it. And in the other case, the other student who knows how to do something well, draw on the screen, and she can do it. So I think there's an opportunity there, but it may very well belong before we talk about Scratch, as opposed to after, when students already have a more technical mental model.
Object code. And object
It
code
does seem dangerous, though, still, in that if the black box in this case is being replaced on stage by a human, then you are sort of implying that the human, or this so-called black box, this function, has the opportunity to kind of go rogue on the instructions and may not actually follow through with their instructions. So in other words, anthropomorphizing I know that's a rough
Today's
one.
word of the day, kids, is
Brought to you by the letter A and
A and a
lot
lot
of
of
headache.
other letters, apparently.
It does seem sort of risky to imply that a computer does have this ability to think about the process, as opposed to it being just, as opposed to just showing a diagram perhaps and saying, this is actually going to be something that always performs some sort of task. So in other words, it seems like you're exchanging one thing for another in terms of abstractness.
Yeah, well, I don't know. I don't know if I agree with that, because one of the hardest things for me early on is I think I can generally explain in a reasonable way what a program is. But then as soon as you talk about functions, I generally, at least in the early part of a semester, describe them as like mini programs that are sort of nested inside. And then things become, I think, a little abstract, right? There's clearly a nuance there between the program itself and the things it's calling. I don't know. I'm not convinced that it's a bad thing, though, to have this physical incarnation of the statements and having them acted out. We could perhaps choose a more interesting example rather than dwell unduly on something that might just come naturally to students. But this ability to say, to define well, and frankly to have the cuteness of like, hello, my name is getString, like there's something about that just works for me. So what we're doing here is something simple, too, that I tried for the first time this year. Usually I'll just put source code on the screen, especially if it's just a few lines. But I spent a few extra minutes beforehand this time and actually changed the color of one line at a time and just used in Keynote some arrows to really draw students' attention visually. Because when you first look at this, we as computer scientists clearly see some structure and a grammar behind the syntax on the screen. But for many students, I dare say that this still looks like Greek to them, so to speak. I mean, they don't know Greek. And so helping them walk through the linearity of the program, top to bottom, left to right, I think is hopefully helpful, so that they start to see this as semantic units, not just a sequence of characters, but there's actually some structure to it, like MAIN has some semantic meaning. And same thing for the parentheses and the curly braces, the semicolon.
Well, this certainly does seem useful, is that you're at least introducing them a little bit to decoupling the syntax from the meaning.
And this was delivered, just as an aside, like when I'm mentioning curly braces, like I do this thinking it's clear to represent like a scratch block, because many of the scratch blocks kind of embrace things like this, like the conditions and the loops. And I actually
thought you were doing your best YMCA impression.
No, whether that's just the C, no.
So why don't you use syntax highlighting in your slides so that there is already some sort of implied level there?
Good question. So one,
Laziness?
Keynote does not make it easy to do so. I could do it in some other program and paste it in or manually do it. But I also, so we might summarize that as laziness, sure. But in this case, there was a linearity here. I didn't care about highlighting everything at once. I wanted to step through it step by step. So in this case, I wouldn't have wanted a syntax highlight this anyway.
Inputs or so-called arguments to a function. Here's one such argument.
But that's true. It does occur to me that when we encourage students to use gedit, a simple text editor in CS50 Explained, we never really talk to them about the fact that everything's color coded. We sort of leave it to them to infer why this is red, why this is blue, or pink, or whatever. And it might not be a bad idea to make explicit mention of like why is gedit highlighting things in the way it is.
You're already sort of loosely touching on this here, is that you're trying to describe a little bit some of the differences between what these words mean and what they mean in the different locations. Like this is an argument.
So I think the simple improvement would be maybe at the end of this demonstration, switch to a syntax highlighted version and say, by the way,
This is what
you'll see in a lot of text editors, even if the colors happen to vary. Yeah, I like that. I'd like to make mental note to fix this next fall.
And I'll send you a little script that allows you to easily syntax highlight in.
Thank you.
in
Oh,
Keynote.
you got that?
Yeah.
This is CS50 improved.
Well, that will.
Week one.
It needs a lot.
Continue.
Yeah, week one continues.
Very long video.
An instruction of programming code that you just want to say.
I had a bit of a tail on me that day.
Are you going to talk about the mic again?
My technical implementation details, yeah, this bothers me. We're going to try to switch to a black cable this year so it blends in with my uniform.
But then it won't necessarily match the skin
No,
tone of your neck.
but fun fact, you can get beige to match my skin tone, and then black to match.
Oh, I can't believe I let you keep talking about that.
Where can I learn more about this technology?
Nope.
Throw up a URL?
Nope.
So
what are we talking about now?
Oh, it's unclear. I disengaged a moment ago.
Gesturing randomly, chopping at the air.
Oh,
Tapping.
okay. So this is my reassurance. So this is actually pedagogically deliberate because I think it's very easy for some students to walk away from a lecture or an introduction to a program. It's like, oh, okay, this isn't that complex, especially if they were comfortable with Scratch. Look how relatively the simple programs are. But then as soon as they go home and start to wrestle with implementing Hello World themselves or something that's slightly more complicated and they just can't get it to work, or very commonly students download the source code from a lecture and think they're doing exactly what I did in class, but they've missed something simple like a semicolon or a parenthesis, and their just eyes and mind aren't trained yet to see those disparities. It can be very frustrating and for no real compelling reason. So what I was deliberately doing there was trying to predict to them that you're absolutely going to run into these headaches for something so simple, or at least simple in retrospect, that to kind of brace them for that so that they don't beat themselves up or think that, oh my God, I just don't get this, when really it happens to everyone.
I actually disagree a little bit with the initial reasoning in that. I think most students that come in totally expect this to be over their head, in that you have the number that you were showing earlier in the year was 78% of students are totally new, and certainly the sort of the feeling of the course on campus is that it is intense, that it is kind of difficult. So most people are coming in maybe even just a little bit nervous about things like this, and simplifying it in lecture is good. You certainly want to be able to provide to them that feeling that it is not going to be as complicated as they want, but I think expressing that in a slightly different way, in that sometimes you will run into errors that will end up being simple, and you don't really want to think of those errors as being like really complicated. You don't want to add that to the stress of everything else that is happening.
I don't know. I think bracing them for some frustration is not a bad thing. Like you want to.
Well, no, that's what I'm saying.
Okay.
But I'm saying that it seems like the reason might be a little bit different in that some of them, they might certainly get some frustration, and they might think. So the way that it's being portrayed here is that it might be a little bit of like trivializing, in that you're saying, oh, it's probably going to be something simple, and many of them might go home and realize, oh, I know this is something simple, but they just can't really figure out what it is. That could be also kind of a frustrating experience.
Yeah,
So
that's fair, but I'd rather they know. Okay, that's fair, but I think we're kind of saying the same thing here. You wouldn't have me not say something, it sounds.
Right.
Like making mention of the fact that predicting that they'll run into these little things doesn't seem like a bad thing.
But I think just expressing it a little bit differently, in that it's okay to struggle with with these things.
Well, yeah,
at
I had
first
no
and
intention not
slowly,
to communicate
right.
that. Yes. Okay. So I think we're saying the
So I'm
same
going to go
thing.
ahead and do this.
Probably.
I'm going to first
Just,
run
you
hello,
know,
Slightly
filling
more
time,
eloquently.
just like you're
as it
doing
was
here in
Monday.
class.
But now I'm going to delete the program, and much
No.
like we
What?
had these
What?
short
Nothing.
names
Sorry, I
last
disengaged
time,
here now.
You were just watching
I am-
yourself talk.
I am
You're just
mesmerized
so-
by this part of the lecture.
At least somebody is.
YouTube count one.
Regular file hello just means we want to delete hello.
Yeah, that's
We
happening
use
right
a char to count our YouTube views here. It's gonna be really sad if we never break 255 on this one.
now. Wow, that's a pretty geeky joke there. So what's going on here? So you're doing a little bit of terminal.
Yeah, early on in the
Explanation.
semester, we don't generally dwell on sort of the mechanics of like the command line, but because we generally defer that to the problem set where we can walk students through and help them and help support them typing some very unfamiliar commands. This is the very start of the semester. This is the second week of the class, and I think it's important to walk through some of these exercises together and try to deliberately trip over some issues like errors that you might see on the screen, so that students, one, can rewind in the video after the fact and find that error and find the solution, or two, just realize that I too fail to type things correctly sometimes and things can go wrong, and to just help them realize that they've seen something before.
LS for list. There's a bunch of
And
stuff
actually,
in
this
here.
is, as an aside, this is something that's key, I think, to do. Like when I said ls and when I typed ls, I also defined it for list. Right? It's the abbreviation of that, because I think too often in technology people say acronyms, and even I accidentally occasionally use an acronym that I take for granted, but someone has never heard before, don't really understand. And so I think it's super important, especially at the start of the term, like just give people a quick parenthetical. It's not going to bother people who are more comfortable. It can surely help people who are less comfortable.
So I imagine most of the questions that we get about this are, okay, have this blinking prompt, but I don't really know what I'm supposed to type. What are the options of things that I could potentially type here? Is
This
that
blinking
covered?
prompt.
Yeah. So I understand you're going over ls and
Yeah.
cd and these sorts of things, and it's relatively basic,
Yeah.
relatively basic stuff. But do we have some sort of a cheat sheet that students
don't,
can
actually.
see at least some more intermediate level or other?
We don't at the moment. Over the years, we've certainly linked to other resources. Right now, I don't believe we have sort of a recommended PDF, like a one-pager, but that's something too we should probably dig up, because that would be useful, especially for the students who want to take their knowledge further and actually get more advanced at the command line. That's a good point. Let's make another mental note here. This is good.
Useful.
Bash no such
As
file
opposed to
directory. So I just
this
renamed it.
discussion
So this
here.
takes a bit of getting used to.
This
but
is-
the problem
this
set
is-
one
he's great.
specification will truly hold your hand through
Um,
some of this minutia,
so
because this is a complete
How much of this, though, is replicated in the problem sets? Because the problem sets are pretty lengthy, and they're meant to
Very much.
do a lot of teaching to the students, even outside of class, sort of self.
This is really,
Paced in
I
some way.
think, the only lecture where I dwell this much on the mechanics of commands and defining them. But there too, I think it's important. many students, and probably most students, have never seen Linux, and most have probably never seen a command line, whether in DOS or in Linux or Unix or Mac OS. So that's why we're dwelling, I think, a little disproportionately today on some of these underlying details.
But in the problem set, how much is addressed?
Oh, significant. And in fact, that was one of the most significant changes we made starting in 2007, whereby the problem set suddenly became much longer in length, not necessarily in challenges and to-dos for the students, but they became much more narrative in the sense that I literally, well, or figuratively tried to hold students' hand throughout the process. By literally typing out or spelling out for them everything they were supposed to type. So rather than say something like, open up your pset1 directory, like I tell them literally, type, click menu, click accessories, click terminal, so as to open a terminal window. Then type cd to ensure you're in your so-called home directory. Then type cd space dropbox/pset1, and so forth, to make sure that no matter what situation they start in, we're hopefully getting them to some default state and then moving to where they want to go. And then you'll find in the psets 1 and 2 and 3 and onward, as soon as I find in writing the spec that I'm starting to repeat myself more than twice or 3 times, then I'll start to take those training wheels off and say parenthetically, remember how, and I'll start to use more succinct language so that they might have to deliberately page back looking for the answer, but that too is meant to be deliberate so that it starts to sink in and they don't just do what I tell them to do.
I'm glad that early on you changed the literally to figuratively.
I
because
know.
It probably violates some law to
I
literally
figuratively
hold
hate how when
every
people
student's
misuse
hand.
literally.
So we compiled CS50's library.
It's like our misspellings piece set, where, yeah,
But nowhere
I can't misspell it
have I specified
incorrectly
that I
anymore
want
because of spell
my
check. It's a little related.
What?
Let's move on.
What? You misspell misspelling?
Deliberately in the problem set.
What is misspelled?
Misspellings. How do you spell
All I've
misspellings?
specified
How do you spell
Excuse us for
misspellings?
just a moment.
Wait, how do you
spell
how do you
misspellings?
spell misspellings?
In our problem set, I spell it as Mispellings. Is that correctly spelled or misspelled?
Sounds like you're missing an S.
Indeed. But that's deliberate. It's ironic because it's a problem set about misspelling.
You're in the 5th grade.
You know, if people wanted just a video about us, we don't have to set up all of this infrastructure.
You mean you're actually talking to students
Yeah.
every semester? Yeah, why don't we just
No,
go
I
with that
mean,
option?
this is CS50 Explained.
Right.
Let's
But
go-
we're explaining,
Uh-huh.
aren't we? No?
Sort of. I think we.
But wait, I missed the
involved
whole
you in
thing.
A typical meal.
I missed the whole thing about you misspell misspellings in the problem.
Forget it,
Like
we'll
a
come
joke?
back to that in a few weeks.
It's like a joke?
It's a joke. It's
Does
a funny
anyone,
joke.
Does anyone realize?
Yes, it's a funny joke. Well, some people
anyone
don't.
emailed
Some
you?
people comment online saying, David, you've misspelled misspellings.
Is that just like an account that you made and you're...
No, it's funny.
No.
It's funny. Get past it.
Oh, you look confused.
Please
What's
write
going
in
on?
to reassure us that this is in fact a funny joke. Comment on this video.
Please direct all correspondence to David Malin at CS50.
So lastly, let's
That's not an address.
reveal one last detail so that there's no magic.
It's okay. The fact that we're going off script so much here, I think, is indicative of just how much we're belaboring the point of mechanics.
Wait, there's a
here.
script?
There's no script.
I wish there was. Something to say.
This is happening real right now.
So we got derailed from the conversation about problem sets. I wanted to talk a little bit more about these ideas. So you have this narrative, and it seems like the problem sets granted are a bit more project-based, where they're supposed to, or a bit project-like, in that the bulk of the assessment isn't these teachable moments that happen during the narrative of remember how to do CD, how to change your directory, how to list all of the contents in the directory, but are instead the much bigger element of actually writing the misspelling piece set, or whichever. It seems like there's an opportunity for those that are replicating the curriculum to take the narrative from the problem sets and break it into possible exercises that can happen in class or even some other assessments. What are your thoughts on that?
It's a good question. That definitely excerpts from the piece sets definitely lend themselves to exercise like opportunities or end of chapter type problems that you might have in a CS textbook. What I've never wanted to do though is to send the message that like knowing CD and mastering LS and all of these other commands are in any way sort of the goal of the course. They're a side effect for sure, and it's absolutely useful to know, but that's not the interesting part of the idea. I want to talk about how they're implemented, sure, but just using them is not necessarily something I would want students to conflate for like the true aim of the PC. So toward that end, we never, ever base assessments on questions like what does CD do or what's the command for doing such. Like I really abhor questions like that. I think it's fine to ask them, maybe to have a warm-up exercise, maybe do them in section. But to be honest, personally, I would stay away from actually using those as part of any form of assessment. I think it's better as a warm-up exercise to something much more meaty than that.
So other than the remember how questions that you use to sort of force students to go back and look up how to do that, is there another way to reinforce these things? Because although certainly it's not the main aspect of the course, you're not teaching people the mechanics of actually how to navigate a computer or what have you, but it is useful to know for these
prerequisites,
right,
for sure.
But how are there other ways that people would be able to reinforce these ideas without making it feel like an
I think
assessment?
the activities or the exercises is fine, but I wouldn't attach necessarily any kind of grade or points to them. You could maybe require them in some form, but I wouldn't generally dwell on those. Because the reality is, so giving students practice with them is useful, but the reality is they will be prerequisite to get to succeeding at the meatier stuff. And so the reality is you're sort of indirectly assessing students' mastery of or at least familiarity with those kinds of mechanics. So exercise is good, but personally I would never ascribe weight to them.
I love this particular example. I hope we see the code. Oh, we blew past it, but a minute or two ago we saw an example of the slide where it was a hello world and you asked the question in class, I believe. You inserted some additional double quotation marks into the string.
Yeah.
Hello, comma, world, backslash n. And you added some additional quotes into the string, but Keynote automatically converted it to the curly quotes, which of course means that it's not actually being broken. And so there's this kind of interesting dichotomy where maybe the most advanced students in the class would be like, those aren't quite the same characters, so you haven't terminated the string.
Yeah, this was Keynote being too helpful, trying to be helpful. This was my fault pedagogically. Like, I should have turned off the annoying feature that changes single quotes and double quotes to curly quotes, which look, instead of going straight up, they instead have this shape to them.
Right.
If only because if students then copy and paste anything I've typed in class in a slide or something else, it's just not going to compile because it's not going to be the valid ASCII character that the compiler is expecting. But it also sends a mixed message too. If you have two quotes that look like this and then two others that look quoted curly, then there is still the symmetry. So that was just amateur hour on my part.
Right. My live demo, it's understandable. But I think the larger point that I wanted to make was that it's useful to provide example code, and if you want to provide broken code, provide it separately from the PDFs from the slides, because PDF readers copy paste. It's very difficult to do it well. So just
and this I do think we've gotten good at. I mean, we make zip files available and directories available of all of the .c files in any other language we do. We do make PDFs of them, mostly for the student who might still want to print them out and annotate on them, which is perfectly fine as well. It's a little easier than leaving it to them to figure out how to open a .c file in a program that prints it nicely with syntax highlighting. So we generate that all for students. But yeah, this was just my typing some code on the fly in Keynote and not having had the thought to avoid that feature. Fixable, but
so tell me about the CS50 library. Where does it come from, and what's the sort of the idea behind it?
yeah, this is the first of relatively few training wheels that I think we have in CS50, where we stray from just built-in functionality of a computer or a language. And it was inspired by a professor at Stanford, actually, Eric Roberts, who wrote the precursor of this library that we used actually when I took CS50 years ago. And we reframed it as the CS50 library and rewrote the code so that the functionality was essentially the same, but it all followed CS50's current style guide and so forth. The function names are deliberately capitalized in kind of an atypical way with a capital G for get, so it's not quite camel case.
String.
Which is mostly for historical reasons, but I sort of rationalize it too, as meaning they look stylistically different from everything else we use to kind of make super clear that this is not built into C.
Have you made that point explicit in class? It seems like something useful to at least mention.
No, and I should, to be honest. I feel like I tell people this, but never in a class context. But the purpose of the library ultimately is to simplify very compelling compelling and common use case, certainly for what we want to do at the beginning of the term, just get user input in various different forms and have it adhere to certain types so that not everything is just a string. And it's a pain in the neck for a student to do that well, right? You can certainly do it with scanf or with getS or other functions, but as soon as you start getting to variable length input like strings, then you have to worry about buffer sizes. And what I wouldn't want to do at the start of the semester in a class that predominantly uses C is send a very dangerous message that, oh sure, just declare an array of this many bytes and hope that the user doesn't type more than that many characters, which so many textbooks do.
It's too much to present this early on in the class. To have to go over arrays and loops
Absolutely.
and just the precise sequence of things to actually go over.
And in fact, the
They will
CS50
see over
library
time.
deliberately leaks memory. Like we use malloc and we return a pointer to a string for getString, but we don't give the student a mechanism for freeing that memory. And I've always had slight misgivings about this because I would love to kind of clean that up. And actually, a couple years ago, we started experimenting with an open source library that actually does automatic garbage collection, so to speak, whereby you link it against your own code and it handles the process of realizing if the string is no longer used in a student's code, it will automatically call free essentially, but it actually started breaking other things. And so we ripped it. I think at the time it didn't play well with other libraries that we used in one or two problem sets, and so it was actually making debugging more complicated, as I recall, or something to that effect, where we solved one problem and introduced another altogether. And I just realized that we can. I'm perfectly comfortable now with just kind of brushing that detail under the rug, the fact that it leaks memory, the fact that it's allocating memory for you, because we don't want to have that conversation yet. We want to have that in a few weeks' time, and then I do bring it up, and I say, by the way, all this time we've been leaking memory, but I think that's okay, because students understand that, and they now know that how to code against it.
You can almost embrace it too, and you can have them do some sort of an exercise where they use Valgrind or whatever to find out how much memory it's actually leaking, or
absolutely.
find out exactly where it's leaking memory.
And nicely enough, it happens in the syllabus that we tend to introduce Valgrind around the time, and we talk about memory leaks around the time we start to take these training wheels off. So it's a tough call, but I think it's absolutely better than using built-in C functions recklessly, or in a way where you have to ask students to understand an array and declare it to get a chunk of memory, and they have to worry about potential overflows.
Do you feel like the CS50 library is pretty complete? Do you think that people that want to use this curriculum can use that and feel as though there are enough training wheels for things that they would potentially want to do?
Yes, though I have toyed with adding a few other functions, like something that allows you to open a file and just read a whole file into a string, for instance.
Seems useful.
Yeah, but and I haven't, because it hasn't really solved a pressing problem, and it's a slippery slope. Then it becomes the sort of PHP of C, where you have everything in the kitchen sink. And so for us right now, we have left the CS50 library in C as just getting user input, and that's it. And I think that's worked fine. And frankly, we rarely use like all of the functions. Get long, some students might use in one of the problem sets to get particularly large numbers. But for the most part, we use it for getString and also for getInt. But what is nice, I think, pedagogically, is mid-semester we'll have a conversation about the CS50 library itself. We don't just take off the training wheels. We actually show students the source code, not only the header file, but also the original .c file. And then we use it as an opportunity to talk about something pretty sophisticated like scanf or scanf in our case, and actually talk to them about how you can dynamically allocate and free memory so that you allocate ultimately just the amount of bytes that you need to source some string. And I think that's a nice challenge mid-semester, because we've now given them the vocabulary and the concepts with which to understand relatively complex code. So here we're introducing some more complex code that we don't dwell on the details of. This is an iUnlock example, a jailbreak exploit from years ago that allowed you to install whatever software you want on your own iPhone. But the connection here that I've always liked, and I use this occasionally in a class briefly, is just like, hey, look, C is actually used, right? Because certainly some students will get a message from their classmates of like, why are you learning C? We're using Java or Python or C++ or any number of other more compelling languages to use to solve most coding problems these days that a student might encounter. But our goal is to build students that understanding from the ground floor up. And so this is meant to be a slight sort of connection to the real world, like, hey, look, people are doing compelling or interesting things with C. But also it's meant to send a message of, even after just a week of class, look at all of these constructs that at least look vaguely familiar. You might not understand the code. Sometimes I might later on what I perceive to be funny comments. This may or may not be intentional. Can we fast forward? There we go. No one saw it. It's rewinding now and pausing, right? But showing that here's a loop, here's a condition, here's some syntax you've seen before, here's some new stuff that just flashed on the screen. But it's just meant to start to help students see past what is foreign to them, or just a week ago was foreign to them. Right? I want them to start to see patterns or similarities so that eventually they can identify what it is they need to look up to understand, what it is they can infer meaning from based on something familiar. And that, I think, is a general skill, to be able to understand things. And in fact, I would argue that's one of the higher order goals of a course like CS50, is to help people understand technology around them. Like, we never talk about how an iPhone works or how an Android phone works, but if you generally understand how an operating system works, because you ran one in a virtual window on your computer, you can start to reason backwards about, why is my phone hanging, or what's crashing? Well, maybe it's because someone has an infinite loop in their code, or maybe because the program took memory that it shouldn't. And it might not help you solve the problem, but it at least takes that mystery out of it, the magic out of it. It's really just a bug in those kinds of cases.
And how much do you really hit this idea home by having students read existing code that is used in the real world? So that was one example.
Yeah.
It was kind of a cool, neat example to show, but perhaps not many students actually do jailbreaks. Maybe some do. But,
nor are we endorsing such.
right. But it's kind of neat that you're able to show that. But what about other examples? Software that students might use on a more regular basis.
That's a good question. Later in the term, we do talk about some popular libraries, Bootstrap, jQuery, this past semester, and we don't walk through students through the code, but it's certainly open source and they can begin to look through that. But more, I think, directly what we do is around PSET 3, we stop expecting students to have a blank gedit window when they start, and we instead give them several hundred lines of distribution code. And in the specification for the problem set, we walk students through that code and we say, look at this, now look here. And in fact, this is super important. You can't just give students distribution code and say, read through this. I think you really do need to provide them with a pathway. And so that's one of the reasons why the specs get longer and longer, so as to explain. And I don't even think comments are enough. In the narrative of the problem set, I propose a linearity. Look here, generally starting with main. Now let's dive into the first function in main, the second function in main. But you kind of want to take them on a verbal or a written tour of the code. And we do that very quickly. I would say perhaps atypically quickly, where we do want students to understand a few hundred lines of code, even though they've been coding in C for just 2 or 3 weeks, so that they can begin to fill in blanks. And we might draw their attention explicitly to those blanks with / to do, write code here. But I think that's okay, if so long as they understand the context. And we try to ensure that they understand the context by having little warm-up questions that tend not to be assessed. We just look, did they submit them or not, in a file called questions.txt. But I ask them questions that I would hope a student who does understand the code should be able to answer correctly. But we're perfectly happy to have them ask someone else, because the goal is just to understand the code, not to get the questions right per se.
So I think we talked about this a little bit in week 1 Monday, the last one, but about this idea of live coding and live demos, and how at least my inclination is that one of the most useful things isn't necessarily just watching you type, because
I'm
still
very
boring.
good at typing, though.
I made that joke on last time as well.
Okay.
But that it's really useful to see when there is a mistake that you didn't anticipate. That is.
Right,
you caught that. Yeah, you caught that right away. But I think pretty soon, if I recall, there's a moment here when there's actually a point where you go into your debug mode. You lean in, you squint at the screen a little bit.
If I lean in or squint, I am genuinely struggling to find a solution.
And you have some other tells as well, like what do you?
If I'm doing this, pretending like I'm asking a very sophisticated question of the audience, that means I have no idea what the solution is, but I'm thinking about it carefully.
What did I accidentally call this file?
Fun fact too, a couple of years ago, I decided we were talking about substrings, and I arbitrarily, on the fly, proposed that cat, C-A-T, is a substring of caterpillar. I think it was in the context of a try, which we'll get to later in the semester. And I swear to God, I was trying to write this down, and it occurred to me, in all of my life, I have never had to type or write the word caterpillar, and therefore had no idea how to spell caterpillar. But apparently every other Harvard student did in the audience, because, I heard it. But thankfully, I typed it into Google, and thankfully Google, bless their heart, said, "Did you mean?" And yes, I did. And so now
Did you do that on the backup computer? Is that what the backup computer is for?
You would think so. That computer's there just to swap in case this one fails somehow.
Or this one fails.
No, I Googled it publicly. So if you go back a year or two, I think you can find my lack of spelling abilities.
Too much work.
Dare I ask you how to spell caterpillar? No, you won't go there. I won't put you in that.
You already asked me to spell something.
Misspellings.
Yeah.
But now this could just be
nailed
our
it.
50 spelling challenge.
Really reminding me of my 5th grade spelling bee when they asked me to spell cassette and I added an S or I
What's a
missed
cassette?
an S.
You're old.
You don't want to
Though I will note here, as a side that might not be clear, so I am super careful when live coding in class to adhere to our own style guide, right? And I would fix mistakes, hopefully, if I stray from it, because I don't want to send a mixed message. So all the spacing, all of the indentation, all of the carriage returns and new lines are consistent with what we would preach to students to do.
Well commented code.
I generally in class, no, that's a good question. In class on the fly, I tend not to comment because I'm doing it more of as a verbal voiceover. But that's a fair point. That wouldn't be bad for me to get more than half out of it. So here is the other bookend video with which we began. The IKEA video was meant to sort of draw people in. And this video, too, is not super germane to the class, but this is the second week of class now. I wanted to end on kind of a fun note and not just my voice about students. And even though this at the end of the day is an advertisement for Google Maps, it's actually a really beautiful story, I think, about a fellow finding his family by way of technology, and that was meant to be one of the messages. And this genuinely moved me when I first saw it, and I thought it would be fun to share at the end of this second week of class where students, especially those less comfortable, are sort of unsure if this is really relevant to them or applies to them.
No, I remember the first time I used Street View. One of the first things I did was find my childhood phone.
Yeah.
That was actually.
Well, you knew where you lived. This was.
Well, no, approximately. I didn't really know the address.
There's a little more to this story that we're talking over.
Well, yeah. I mean, certainly. Not trying to equate at all, but just that it was interesting that there was. That there is.
Creepy though that you can see this aerial satellite photography of your home.
No, this is Street View itself. You could
That's
actually
even
see.
creepier.
Yeah, you could actually see how they kind of let it go a little bit. They cut down the tree that I used to climb on. I was very sad about that.
This is Dan Armendariz Explained.
As opposed to you talking about the color of the wire that goes from your Britney Spears style.
People want to know.
Nobody wants to know. People care about the tree.
I've forgotten much of that story. So after this video, you'll see me adjourn with a deep dive.
Don't spoil it. Just wait for it. Wait for it.
And now they know.
They're already fast forwarding through this part just to get to the video at the end.
Standing outside adjacent to each other.
I do like, I think this might have been new this year, the
This is your mother.
sort of projector style, the fact that there's a dimmed Sanders in the background of the video, and even now it's very
subtle.
meta. We're watching a video in Sanders. Right now, people are watching a video of us, watching a video in Sanders, watching a
This is
video.
CS50 Explained. Yeah, got it.
Explain, yeah. Very meta.
Yeah,
Yo
that was
dog.
deliberate because
Is
we
that a
deliberately.
joke that I can make? Yo dog?
Everything's all
I
good.
heard you like Sanders.
Oh, that's.
She doesn't
Is
have
that-
to be
no?
slaving away.
No.
She can live the rest of her
So
life.
Do you not understand
we
the reference?
deliberately. No, I'm gonna Google it later. We deliberately switched to a 2:40 aspect ratio this year, which essentially means super widescreen. Couldn't hold that 2 more minutes, which means that we shoot in more of a cinematic aspect ratio like you would see in the actual movies, but the computer projector and other assets are all 16:9,
Trying to make it more interesting.
and so
But-
we needed to fill that space somehow.
Okay, here it is.
Oh, there's a deep thought at the end of this class by Davin Farnham.
I love that there's actually Toasty
I keep my CS50
This
Explained
is actually one of
kitchen.
my favorites.
Yeah.
I make
Oh, that's it.
Yep.
Week one.